They will bend. Okay, these are the rays. So let's take the lens now. We have there's a shape not good. Huh? Please do understand it. It's a lens. Huh? Okay, that one. Yeah, fine. Now there's an objective lens, and there's an eyepiece lens. Where's the object? I should not show HO here. Will I agree this? So what are this? These are the rays coming from far away object. So there's a ray 1. So this is the rays, incident rays from distant object. Distant, agree this, far away object. Rays, incident rays from distant object or heavenly object, or say from moon. Let me take good example. Distant object is say moon. We are viewing the moon. So the rays what happen? So as they are coming from infinity, what will happen? Where they should come and converge? Where they should come and converge? Or all they should come and converge at the focal length. No? The image I1 this is. So what is this distance should be? This must be equal to F naught. Agree this? I think this everyone accept this one. Usually in ray optics, what when we just shown the rays coming parallel to principal axis here. Sir, why can't the rays come parallel to principal axis? I think look at the position of the earth and heavenly object, that one. What all the rays, what happen? They will come like this. Even the some set of rays will come here. I didn't show. Don't think that only on upper part of objective lens the rays, incident rays are incident. Nothing. Even the rays will come here. But altogether, what will happen when you view any object? No, so the rays will be captured here. Okay, this one. So the final what happened? The rays will converge at a point at the focal length of the objective. That is what I1. Again, the rays what happen after that? The further traverse. The further traverse here. So they'll get reflected. So I think they'll form the final image. Red color one. Okay, I think my image got over. Yeah. That blue color one is a reference. The ray which will pass through this will go undeviated. Afterwards, it will come. So if you want, you can show that. Just only the ray which will pass through the optic center should go undeviated. The rays which are not passing through optic center will undergo deviation. For that purpose, I took the blue color ray. Okay, fine. So this is the final our image will be. It's a virtual only. Let me show by a solid line because all are dotted. No, this is I2, H2. Call this is H1. I think our triangle will come. Let me adjust it. So this will be. This is the human eye. This is our final image. H2. This is I2. Okay, these are the rays. 3 arrows. I'll show it. 2 arrows. This is one. Finally, this will be 2 arrows. So what is the image? Image will be virtual. So these are the rays coming from far away object here. Now, what is the alpha and the beta? It is defined. Beta and alpha defined in same direction. So what is the magnifying power for a telescope? First of all, we should define what is the magnifying power, no? And there's the UV, and this is VE, the image distance, and FE will come somewhere here. This is F naught till here. All the distances I indicate. Just see once. Okay, now let's get into the calculation part. First, how to define the magnifying power? That's the same definition. Magnifying power for a telescope is defined as the ratio of it is the ratio of the angle subtended at the eye by the image to the angle subtended at the unaided eye by the object. Means if these two lenses were not there, so what is the direction of that angle of incidence? That's why I took the blue color ray, that one. So these are the rays. What happens? They'll enter into the eye. They'll enter into the eye. If this lens also not there, so they'll enter. Eye is placed here. So what is the angle subtended by the blue color rays without any lenses? It will be alpha. That we have to show that undeviated. The blue color ray. Okay, it is for our reference. We have to show that undeviated. Okay, this one. This is undeviated ray without lenses. If there were no objective and eyepiece lens, okay, the ray what happened would have gone undeviated. Even all these also, the red color or even the violet color rays, all they go undeviated, and they're incident at an angle alpha. They're incident at an angle alpha here. So therefore, the magnifying power, the very basic definition, what it says like, I'll define the definition. This is for telescope. It's defined as angle subtended at the eye by the image with the help of instrument divided by angle subtended at the unaided eye by the object, by the distant object. Okay, fine. I think that in microscope, what happened? This was the object kept at a least distance of distinct vision. So here what happened? The angle subtended by the incident rays at the unaided eye. And what is that incident is coming from distant object here. So therefore that alpha is what I should indicate here. I think this is something very important. In the books, what when they defined it, that distant at least that is not there. These words are not there. That's why you'll get often confused here. So what is a beta? I think from the diagram, beta by alpha is what our magnifying power for a telescope. Now, what is beta? You can look at from there. Beta shall we write H2 by VE. You look at the bigger triangle. This triangle H2 by VE beta. Tan beta it is. Tan beta we can write as. What is alpha? From where to bring alpha? Alpha is what you can also write H1 by how to bring alpha, that one. So alpha can be write H1 by F naught, because that's the only thing is available here, no? So look at this triangle. You have to look at this triangle. Able to make it out? I'm just telling this one. This alpha or H1 by F naught. Okay, then I'll give some small help. Let's have some small basic diagrams. This is H2, this is H1, this is V naught, this is VE. Okay, I think so. Now H2 by VE, you can also write it as what? H1 by UE. So finally, what is this magnification? F naught by UE. There's a total magnification what we get. And what is UE? It all the distance of the image, the distance of the image, this one, this in terms of this I'm bringing. So how to eliminate UE? UE is unknown. So shall we use again the length formula? So this is VE, no? So by using from the optics 1 by VE. So shall I replace this UE value? This will be negative, this will be negative. Depending upon that one. And if it is the least distance of distant vision, we can write it. Okay, let me, I think I'll come to later on. No? There's a core central part of our discussion. where we are. It is here. I think I can show only this much. There's a minimum thing. Now we'll go for if the image is at near point. Image at near point means I2 will be at 25 centimeter. Then what I should do with the UE? I should calculate the required the UE value in terms of that capital D, that one. If the image is that far away, then UE will become equal to FE. So first, like image formed at near point. If the final image is at D equal to 25 centimeter or near point. So I think that the old diagram is just very simple. The same diagram, only this, what will happen to this VE will become 25 centimeter. I'll give the diagram. No need to, for you in exams, so only I think somehow if you can remember one diagram, that is enough. No need to remember three diagrams here. Only the values will change a little bit. This is our topic of discussion. So this VE, what shall I write? Equal to 25 centimeter, or nothing but this will become equal to capital D. Both are same. So what you want to say is, as I'm seeing it not comfortably. So when you can see comfortably? When the rays enter parallelly into the eye. When the rays enter parallelly into there. So how to calculate that you know that has to be eliminated, no? So let's go for the formula. 1 by VE, 1 by FE. So this is minus D 1 by D plus 1 by FE. So then what is the magnifying power formula? M25. This should be equal to what, like F naught. In place of 1 by UE, I should write 1 by DE plus 1 by FE. I think better to remember this formula here. So this is a magnifying power. Here we can write in one more way. D plus FE by DFE. Or this will become F naught by FE 1 plus plus you have to remember this formula, very important. It's left to you. If you are able to derive an exam, okay, go for it. Now, what is the length of the tube? This is what length of the tube, L25. Not 25 centimeter length of the tube. D is 25 means L25 will not be 25. Symbols we are giving that one. So what is L25 should be equal to? This should be equal to F naught plus UE, no? You see what is this distance will be? Length of the telescope or length of the tube it is called as. So F naught plus this distance UE. What is UE? We have value here. UE should be equal to DFE okay, these are the two formulas. So when to use this formula? When final image is formed at distance of least distance of distinct vision. Okay, now I can adjust things in such a way that final image will be at infinity. So shall we adjust the objective? So object is moon, no? Moon, heavenly object. You can't do anything with the object. Just keep it as it is. So what you should do? You can change the distance between the eyepiece, objective and eyepiece, such that what happen? The final image what happen will be at infinity. For that, how the rays after refraction should become parallel. Then we should calculate what is the magnifying power and what is the length of the tube. Final image at infinity. Or 4 point. According to terminology, you can just say final limit infinity or 4 point, or or this called like also 4 point, or comfortable weaving or normal weaving. Any of the things can be asked. So what I should do? So I should not show this. This should not be visible. The rays, what happen after refraction? They should become parallel. I'll redraw it all again. This will be, there's a line. No? Red color. Okay, I think they are parallel. Huh? I'm showing parallel rays. Yeah. Okay, this will be L infinity. Don't show this final image. This will be enough. This is also called as normal adjustment. This condition. So what humanize says, humanize what it says like, I'm weaving magnified image of heavenly object comfortably. Any reason for that? The rays will enter parallelly into the eye. Red color to this one. Okay, let's get into the calculation. Okay, directly let's come forward. What is the magnifying power? Magnifying power will be beta by alpha. So in this case, Fe, and this is UV. And where is the focal length? Focal length will be here only. So what is beta? Beta will be or else I think I'll come for this. What is UV? F naught by UV in the formula. What is UV? UV will become FE. So this is M infinity, you write it. So there's a magnifying power when the image is at infinity. Means this is something in books or pen, they're given another diagram. They're given diagram like this. This is the objective, this is the objective, there's the eyepiece, and the rays are coming from the distant object. Books, they're given diagram of this kind. So it's nothing wrong. And these are high. Some students, they're asking like this. Sir, object at infinity, image at infinity. Then what we see? Object far away, we're unable to see. Then image at infinity, we're unable to see. Then what we'll see? We will see that distant object only. I'll give now relative diagram, little bit. This is about only ray diagram. You find very difficult. What is actually all this? Just because we are not seeing anything, no, just only rays with the rays. How do we can visualize what actually going on? Object. This is like a rays from distant star or moon, anything, and we are able to see. If you ask human eye, what you're seeing, I'm seeing that distant star. There's the length of the tube. This is called like a normal adjustment. In normal adjustment, this is what happens. So what is the length of the tube? F naught plus Fe. What is this length should be equal to? F naught, and this length is equal to Fe. So what is the length of the tube? Usually telescope is always used in normal adjustment. The telescope is always used in normal adjustment here. This is like when final image is at infinity. Okay, fine. So this is about the theoretical idea. So now let's see that. I'll just show for this. For image at 25 centimeter, I'll show that how do that image what we actually see that one. So if you look at the we'll go for one small rough diagram. So this is the actually there's a moon, there's a earth, and we have here telescope, and there's a person is seeing that one. So the rays emitted by the moon, what will happen? Its image will be brought near to the telescope. So it will be somewhere. This is the objective. So shall I write only F naught? This Fe, and there's a person. So what will be visible for image? This image will be visible here. Its image will be brought here. So the object which was far away. So look at the object here. So the object which was far away, after undergoing refraction from its image will be formed. So what is this? What is this? I should call now. So I'll give at least. There's a trick of this particular instrument. Nothing is there. It will not bring moon near to your eyes. It will form the image of that moon near to the eye. So what can be the diameter? I think that the distance of the diameter of the moon is very big. But what is it? This image will be of order diameter 5 or 6 centimeter. It's good. It's good that one. You can see clearly things. It will not form the exact shape. The image will not be the so like dimensions of the moon. Will be small then. What will be the image now? What is the diameter of this image? Will be of order 5 or 10. It all depends on telescope here. And that is enough that one. We can see things very clearly. And when you remove this telescope, person will see the moon. When a person sees the moon through telescope, what will be visible? Is it the real moon or the image of the moon? Image of the moon is visible. Please, I think you should have common sense enough. Huh? Without telescope, you'll see the moon. But sir, like a moon is bigger. So I think you look at the moon. How do it appear for you? Around 1 centimeter. No, I think you can just see the moon. I think now you'll get a Purnami something after another. I think another 7 days. I think next coming Thursday Purnami will be there. A full moon day. Just try to see that one. What is the dimensions of the moon you see? Around 1 or 2 centimeter. You take scale and see, keep like this. Then what is the diameter of the moon? You can measure from your viewing angle. So 1 or 2 centimeter. The telescope will form the image of moon, which will be of order diameter 6 to 10. It all depends upon the shape of the telescope. That one. Select around 10 centimeter. Good, no? The object which you are viewing with the diameter is 2 centimeter. The same object is available as now how much it is? 10 centimeter. Enough, no? You got magnified. You are able to see it. This is what happens with telescope. Got the idea? So the basic thing. So in fact, a refraction. Sir, what about the intermediate image? Intermediate image you can't see. The final image, intermediate image will be there. That is not visible. So don't think that sir, 3 moons I'll see. One original, intermediate moon, then final image moon. No, you'll see only one moon. Again, this answer, I have 2 eyes. With one eye I'll see this. With one eye I'll see this. Check it, not possible. That's why we'll close one eye. So that what happen? You can easily perceive that particular thing. Because the dimensions of this lens will not be very big, no? So that one eye will be placed at the eyepiece of the lens. So that you can see that clearly thing. So for every 1 minute, what happens? You have to change the position of eye. Otherwise, eye will get strained.